Hello from Gothenburg, Nebraska. My name is Brett Lynn, a trainee at the Bear Water Utilization Learning Center. This is the second video in a series covering the 350th anniversary of the discovery of phosphorus as an element. If you hadn't had the opportunity to view the first video, I highly suggest you watch that first, as these videos will build upon one another. In the previous video, we discussed the 17 essential plant nutrients, yield limitations, and the history and importance of phosphorus. This video, we're going to explore phosphorus behavior both in soil and plants, as well as the social and environmental concerns surrounding phosphorus as a nutrient source. Phosphorus often lives in the shadow of nitrogen when we're discussing our nutrient management plans. Nitrogen is a very dynamic nutrient that provides some interesting challenges. And because of how much we talk about nitrogen, some of us may be a little more comfortable and familiar with that nutrient. So briefly, I'd like to compare and contrast nitrogen and phosphorus so we can become a little more familiar with phosphorus and see how it is similar and unique from nitrogen. In the soil, nitrogen moves about via mass flow, which in essence is nitrogen moving with the flow of water. Phosphorus, however, moves via diffusion, or from an area where phosphorus is highly concentrated to an area where it is lowly concentrated. To compare the two speeds of these processes, mass flow can be thought of driving to the grocery store, whereas diffusion can be thought of as walking to the grocery store. So nitrogen does like to move about our soil profile quite a bit, whereas phosphorus is a little more lethargic in the soil profile. Nitrogen can often serve as an energy source for our soil microbes, which leads to a loss pathway for nitrogen. Phosphorus is a little different. It's a social element, so it likes to interact with other elements in the soil, such as calcium and aluminum. When it interacts with these elements, it can actually precipitate out or form an insoluble compound and become unavailable to the plants. Briefly, for those who are interested, the two plant available forms in soil of nitrogen are ammonium, or NH4 plus, and nitrate, or NO3 minus, whereas the plant available forms of phosphorus in soil are predominantly orthophosphates, or H2PO4 minus, or HPO4 2 minus. Which form will be available to the plant is predominantly dependent on soil pH. In the plant, both nutrients are mobile. However, the deficiencies will manifest differently. Nitrogen deficiency will show up in the lower leaves along the midrib, and it will be yellow. Whereas phosphorus deficiency will show up in the lower leaves and will be along the leaf margins, and it will manifest as purple. An example of a healthy corn leaf, a phosphorus deficient corn leaf, and a nitrogen deficient corn leaf can be seen in the upper right hand corner. Outside of agricultural production, phosphorus fertilizer has actually seen a fair bit of attention in recent years, and that is largely due to a word known as eutrophication. We may have seen this circulating in various media outlets. Essentially, what eutrophication means is nutrient enrichment. When phosphorus is carried off-site, it can enter our freshwater ecosystems. Our freshwater ecosystems are phosphorus limited. When there's an abundance of phosphorus, algae blooms can occur. Depending on the severity and type of algae that blooms, this can lead to several adverse outcomes, such as impaired drinking water or fish die-offs. So it's important from an agricultural standpoint as well as an environmental standpoint that we try our best to keep the phosphorus on site. And in later videos, we will discuss strategies to do exactly that. If we're going to talk about the environmental consequences of phosphorus as a nutrient source, it is also important that we establish a couple key vocabulary words. The first is point source pollution. Point source pollution can be thought of in the context of phosphorus, a highly concentrated area of phosphorus, such as in a confined animal feeding operation or CAFO, where there are vast amounts of manure generated. When the manure is piled up, there is one area that can be pinpointed as to where the nutrient is coming from, whereas a non-point source would be the application of fertilizer and the transportation of that fertilizer off the field. It's not highly concentrated in one particular area. However, the effect accumulates over a large area. Again, these are just a couple terms to be familiar with because they typically are accompanying any discussion that is focused on eutrophication and protecting our fresh water bodies from off-target phosphorus movement. I thank you for your time and look forward to discussing nutrient stewardship with you in the next video.